the second lab of Physics 1, motion of a slow falling object. My name is Mason Hardwick, and let's get started. Okay, so the motion of a leaf was tracked falling down in this lab. 3 different position versus time models were used to represent the falling of the leaf. The empirical model was generated using Tracker, and there were 2 computational models generated in GlowScript. One took into account the force of gravity and drag, and the other just took into account the force of gravity. The goal of this experiment is to deduce and predict the effects of gravity and drag on an object's motion. So there were several principles used in modeling for this experiment. Those are Newton's second law, which you can see right here, the equation for the force of gravity, the equation for that's right here, and drag force right here. So the mass of the leaf was measured, and that is recorded right here, and that will also be in our data down there, like in further slides. And we also recorded initial position and final position. Here's the leaf as it fell, and yeah, so here this data was used in the coding. So here are the initial calculations. We just plugged in the data from the previous slide into this code, and as you can see, we're doing the simulation without the drag force, and so the only force that we're accounting for is the force of gravity right here. And as you can see, that is represented in our free body diagram, and you can see that only one force acting on the object causes the velocity to change linearly with time. So as time goes on, the force acts on the object and it changes the velocity, but it's only one force, so it's linear. That means the slope is constant, and so that's why you see this linear line. So when we include drag in our calculations, our initial conditions don't really change, but what does change is our like simulation conditions, where you see we have accounted for the force of gravity and we've accounted for the force of drag in our calculations, and you can see that in our free body diagram as well, where you see this is the force of gravity and that's the force of drag. It also is evident in our velocity versus time graph, where you can see the velocity approaches a value, but not linearly as the previous velocity versus time graph did. The slope of the velocity versus time graph decreases over time, which indicates that the drag force is acting to counteract gravity as time goes on, and so the velocity slowly approaches this value, which represents the terminal velocity. So as you can see, the model, a position with the drag force, lined up best with the experimental position. The model, a position without the drag force, has a much steeper slope right here than the model, a position with the drag force, as well as the experimental position. This is because the drag force slows the leaf down, decreasing the magnitude of acceleration, and therefore the slope of position over time in models, it's like the slope of position over time is more steep than in models that account for the drag force. So we will take a closer look at velocity here, and we'll see that as the velocity, when we account for the drag force, as time increases, the velocity always approaches this value, which represents the terminal velocity. But so the model with the drag force predicts the terminal velocity, where the forces of gravity and the force of drag are equal in magnitude, and you can know that they're equal because the slope of this velocity is constant. It doesn't really change, and so that's why you can tell that there's a net force of 0 when the drag force and force of gravity are accounted for. So if the object was thrown down instead of just dropped, then that would change the initial velocity of the object, but it does not change the terminal velocity of the object, and so you can see that changes the rate that the object approaches the terminal velocity, but it does not change the terminal velocity that it approaches. As you can see, it's approaching a little bit less than 2.5 in all 3 of these graphs, whereas the slopes of all 3 of these graphs are all a little bit different.